This is going to be a high-level overview of Hibernate, the Object Relational Mapping API. Now, if you go to Wikipedia, the Hibernate page, you can get some information on its history and the various high-level parts. Essentially what it is, it's an object relational mapper which allows you to create what are known as entity objects. So Hibernate is a Java API, and there's something called Nhibernate, which is for the .NET, Microsoft.NET platform, and it's written in C#. So what it does is it allows you to create objects in those languages, and those objects are considered to be persistence objects. And using the Hibernate Entity Manager, you can persist those objects and retrieve those objects and do queries on them. Now, Hibernate has been around for quite a while. May 2001 was when it was the initial release, and that's actually 19 years now. Latest release is 5.4.10. So they've been continuously working on this and making it better and better all those years. But what an ORM allows you to do is to design your database using objects rather than relational tables. So before an ORM, you had to go in and create a relational database schema. So you'd have to plan out all the tables, all the relationships between the tables, etc. And so that was usually done by an experienced DBA, database architect, and you needed quite a bit of skill to do that. So it was another step that you had to do, extra work, etc. This allows you, as a object-oriented developer, to use that same object orientation experience to design your database. And it's a different way of thinking about your data with regards to relational databases. That's a whole different thing. So Hibernate took off, and it seems to be pretty extensively used now. Let's see, if we go down here, Hibernate has a query language called HQL. It's very similar to SQL, but except you don't refer to tables, you refer to the objects themselves. The persistence is based on just POJOs, so plain old objects, plain old Java objects, and these objects are annotated with Hibernate annotations. So, I keep saying Hibernate. Hibernate basically came up with this architecture. But so a few years back, there was a JSR to create a persistence API. And so the Java Persistence API, you can see this too, you can read this as well. It pretty much just used the Hibernate architecture for the JPA. And I think some of the Hibernate engineers helped to build this, to define this API. So this API is really a specification. It's not an implementation, but Hibernate is an approved or a certified, I'm not sure, implementation of the JPA. So, but when you do your coding, Hibernate has extra stuff that's not defined in the JPA. And who knows if, they're still evolving the JPA, so you never know what Hibernate attributes will go into the JPA in the future, but there are attributes from Hibernate that you can still use, because if you're using Hibernate, those will be available to you. But you probably want to stick with the JPAI as much as you can, just because that means that your code, if you wrote your code specifically using only the JPA, that means if you went to a different JPA implementation, you wouldn't have to mess with any of your code. If you use Hibernate stuff, annotations, then you might have to do some extra work on your code. So let's see here. Anything else in here I want to talk about? Yeah, so there's other vendors that support JPA 2.0. Here's the list. I think Hibernate's probably the most popular. I'm not sure at this point, but I guess the JPA is at 2.2 at this point. And so if we look at the Hibernate's query language, as I mentioned before, is HQL. And Java also folded into the JPA. If you go to it has a Java persistence query language that's folded into it's part of the JPA's specification. And if you go to that on Wikipedia, or if you go to Hibernate query language, it will direct you to the JPQL language. So it looks like JPA just adopted Hibernate's HQL specification. And so what the HQL can do, so here's a example. Select A from author, which is an object, A, where the last name is null or lower last, so you're passing in this last name as your query attribute. And it's going to return a list of authors. And if we look at the author object, this is an entity object. It's a POJO. It has the author name, first name, last name, and then it has a many-to-many relationship, a list of books. So when you use this HQL query, you're going to get a list of authors that match this author's name, and it's going to have a list of books that author had a part in writing. So then if you iterate through the books, you'll see a book has a title and an ISBN, has a publisher. So you're going to get the publisher of that book that he authored, and then you're going to have a list of authors, so you can find other authors that also worked on that same book, because some books have 2, 3, 4 authors. So you get all of this And then you also get the publisher, which has a list of books that are also published by this publisher. So you get all of that just for this query. If you had to do it in SQL, regular SQL, you'd have to do, this from the author table, and then an and do another select from the book table, and then another select from the publisher table, and it would join all that together, and then you would get a big table back with all of those rows that matched, and some of the tables would be null because they wouldn't be applicable, that kind of stuff. So you can see this is a very elegant way to interact with a relational database, because you get the results from your queries are all in objects, and there's no superfluous information or fields that don't have anything to do with these objects. All right, so what I'm going to do, I have an application that I wrote, and I'm going to use that as an example so that I can show you some real code. And the application is called iManager, and if you go to this website and click on iManager here, you'll see this page, and down here is a download link. It's a zip file, and so when you download it, it will create a zip. It'll be this zip file, and if you unzip it, it creates this folder. And so inside this folder, you'll see a bin folder, and inside here you will see two batch files. One's called start HSQLDB bat, and the other one is run iManager HSQLDB bat. And so in order to run these, you're going to need the JDK installed, or the JRE. You don't really need the JDK, but if you plan on developing some software with Hibernate, you're going to need the JDK. And if you install the JDK, you don't need the JRE, because the JRE comes with the JDK. But to run this, you don't actually need the JDK. You can just use the JRE. So once you install the JDK, let's say that's what you did, it's going to get put into the program files folder, and you'll see a folder called Java. And if you click on that, you go in there, you'll see the version of Java that you downloaded, or that you installed. I would recommend Java 1.8. You can go to a higher one, but this program, I know it runs on Java 1.8, and you can install multiple versions of Java, so you can have more than one version in the same, that they will show up in this same folder. So the thing is that these batch files, they need an environment variable called Java Home to find where your Java is located. So to do that, what you can do is go to the search bar in Windows 10 and type system, and you'll see this system app. So just run that, and then when that comes up, click on Advanced System Settings, and then click Environment Variables, and you will go to the System Variables section and type New, and type Java Home, like that. And then you go here, go into the JDK or JRE folder. If you're going to do JRE, you would name this JRE instead of Java Home. You would put JRE here. But since I installed the Java Home, or the JDK, I'm going to put Java Home. And I'll go into my JDK folder and click the address bar and then copy that. And then just put it here, paste it here, and then click OK. And since I already have one, which is right here, I'm not going to do that. I already created one. So you would just, after you clicked OK on the last dialog, you would then say OK, OK, and then you can close this. And so now, after you've done that, now you can run both of these. So this right here, you need to run first. And basically, it's a relational database, but it's an in-memory relational database, and it's a standalone database. You don't have, it doesn't install a server or anything. It just opens up a console window, starts up, and then you just minimize it. So I'll do that now. Start the database up. So now it's started, and I can just minimize it. And this is a real relational database. And so for the to show the database tables for examples, I'm going to run the HSQL database. Comes with a manager GUI. So I'm going to start that up now just by double clicking on that. Under the bin DB tools, there's a batch file that will start it there. So now it's started. I can minimize this because I don't need it anymore. And this will let us look at the relational database tables that gets created by Hibernate. And so I'm going to use Netbeans for my project, my iManager project. I used Netbeans 8.2 IDE to develop this application. The reason I did that is because this application is a swing application, and the Netbeans IDE is very good, has a very good visual editor in it. I can show you that. So I'll go into the project here, go to UI, I'll go to the edit item JPanel, and that'll load up. So this is what the item dialog looks like. And what I'm going to do now is I'm going to run the application so we can get that up and running. I don't need this anymore. So I'm going to start the iManager application, and it comes up here. I'm going to log it in. It doesn't have a username and login just because this is a beta application. So now the system is up. So let me bring up an item. Actually, let's go to 339. 339. So so this item here, this is the design, and this is what it looks like in the application. So over here, this is your palette, and you have all of these controls that you can use, and if you want to use one, you just drag it over and drop it over on your panel. And so if you click on one of these, you'll see this is the component for that J panel. If I click on that, you'll see where it belongs, where it's on the actual panel. It highlights it, and then it shows you all the attributes over here for that particular control. So that's why this IDE is pretty good for making Swing applications. And Swing, Java Swing is a very extensive UI development API, and you can customize any of these controls. If you want, you can stylize this so that it looks exactly like a modern Windows dialog, that kind of stuff. It's endless what you can do with it. But of course, it's for thick client apps, so it's not for web work. But enough of that, because this is more about Hibernate. And you can get Netbeans IDE from the Oracle site, the same place that you get Java. And I think you can download a bundled zip file that has Netbeans as well as the JDK with it. Or you can download them separately. It's up to you. So what I've done here in this application, I have a folder for all the UI stuff, and then I have a folder for persistence objects. So the way that Hibernate and JPA works is you generally have these POJOs that are written basically just to describe the entity objects. So if I go into this item, so this item is the main item, or the main persistence object, or persistence entity object, that stores information for an item. So if we go back to the application, the information for this item is the item number, and this happens to be 321.339, the product line that it belongs to, other things like, is it back ordered, is it discontinued, is there a superseded number, the prices for this item, and other things like the order point, the new order, popularity code of this item, these codes here, the OEM product number, if it has one, and then sales information down here. It's got the product line name for this thing. So all of this information is associated with an item. So you'll notice something else. So here's a bin location, and then you see this thing over here called store. So this application, this iManager application, supports a multi-store capability. So, this is a distributed application. It uses a SQL database, so you can use any kind of SQL database like MySQL, PostgreSQL. Right now we're using the HS SQL database. You could use SQL Server. You could use AWS hosting a MySQL server. So as long as that server is accessible on the internet, you could run this and connect to it anywhere. So you could have people accessing from a store in one location and then in another store, say across the country or just across town. It doesn't really matter. They'll both have access to the same inventory repository, data repository. So that means that we have some of these items, some of these data attributes for an item are going to be applicable to any store anywhere, such as the item number, also such as the product line, also such as the prices, because the prices are going to be sold. The prices that this gets sold at are going to be the same for any store. But other things, and also the description of the item, and let's say the picture of the item, that's going to be the same for every store. So these items, like the price, the item number, the product line, are going to be part of this item object. So right now I'm kind of describing the design of my data model. So you're going to have this item, which is the main, that stores the main information about the item. And then, but there's other data that's going to be specific to a store. So we have to model that as well. So if we go to the item entity object, the first thing you're going to see is you're going to see all of these imports here, and they say JavaX, persistence, and then the JPA item that I'm pulling in. So this JavaX is Java extensions persistence. These are from the JPA standard that I talked about earlier in the on the Wikipedia article. So these are the ones that were pretty much adopted from Hibernate. So Java took this from Hibernate when they designed the JPA, Java Persistence API. But here you see down here I'm importing some stuff from Hibernate. So these are annotations. These are annotations up here, but these are also annotations, but they're Hibernate annotations. So this fetch and fetch mode and where, these are directives that they're annotations that are put upon objects that give extra information to Hibernate on how to do things with regard to working with the database. So generally you want to just use the JPA annotations because that would insulate this object, this entity object, from using other implementations of the JPA ORM. So if I wanted to switch from Hibernate to some other implementation, manufacturer's implementation, they may or may not implement these. And if they didn't, I would be in trouble. I would have to figure out, I'd have to go in and modify code. If I'm using these in a lot of different entity objects, I'd have to go in and mess around with the code and figure out how to at least get the same capability in that other ORM. But if you use nothing but JPA annotations, you would not have to do anything to your code. So I'm just mentioning that. Sometimes, though, there are things in Hibernate that you just got to use. And these will probably end up being JPA attributes or annotations eventually, if they make sense for the JPA. So now let's look at the object. This is a POJO, a plain old Java object. It's just basically just a basic POJO. It's attributes or member variables and getters and setters, pretty much. So, but one thing you'll notice is this is where we start using JPA annotations. These are called annotations. and I'm sure you're probably familiar with that, but if you're not, all this does is this is metadata to tell APIs what things mean. So I won't go into these other ones right now. These are a little bit more advanced. But the thing you need to really emphasize here is if you want to create a Java object and create an entity object out of it, which means it's going to be persisted to the database, you need to have this @entity at the top of the declaration of the Java class. So if we come down here, we see public class item. So this entity is on top of this class, so that's a directive to tell it that, hey, this is a persistent object. And you need to implement serializable. So every one of your entity objects will need to implement that, which is essentially just putting this here. You don't really have to implement anything for this to work, unless you have a very if you have a complicated object, you may need to implement a override this default serializable, or this, because there is a default, even though I have no serializable method. Java knows how to serialize all of these primitive types. All of these primitive types are serializable. So, but most of your objects themselves will be made up of, ultimately, of primitive types. Even though they may have other objects, those objects will ultimately end up with primitive types. So it just cascades. You don't need this comparable. I needed it to compare these, have a comparative method to compare two of these items. So, but you don't need to implement comparable if you don't need to. So let's move on into the object. So here you see this annotation called transient, and that's not the same annotation, Java annotation, which is transient, I believe. Transient? Yeah. So this is the Java annotation or directive to tell it not to serialize but this transient here is the Hibernate or JPA annotation. I believe it is, yeah. It's a JPA annotation to tell Hibernate, do not even worry about this. Do not try to persist this. Same goes with this Java serial number. The serial number, if you're not familiar with the Java serial number, it has to do with serializability or serializable objects, because Java was originally created to be the language of the network. That was their tagline when they first came out with Java. And so one of the things that they built in, I believe, from the very start of creating Java was its ability to serialize objects, so that if you had an application that was on the network, you could ask another application on another network node to send it an object. And so it would serialize that over the network, and then when you your application received it, it would just marshal it into another object of that type and give you that object. The problem is that depending on that other, the version of that other application, you may have updated your version, let's say. You may have added some more attributes. And so if the other application on the other network node has a different version of that application without those attributes, you're going to serialize this over, or that other application is going to serialize that object back to you, and it's going to be expecting, like, say, 3 extra attributes, and they're not going to be there. So your version will not match the version that they have on the other application, the older application. So you can write code that will take care of that. It will skip those attributes and let you still materialize that object. But I'm now digressing, so let's move on. You can learn more about that if you want. So we see we know what the transient annotation is. Now we have this annotation called ID. So you need to have an ID in every one of your entity objects, and it's very simple. It's easy to do. You really don't have to think about this. You just create this annotation. You can use this. I use this on all of my entity objects. Just let Hibernate decide the best way to generate a primary key. This is going to be the primary. By the way, this is the primary key of this object. When it's it's the equivalent of the database table's primary key. And so this annotation here just says to Hibernate, hey, you go ahead and decide the best way to create a primary key for whatever database you might be working with, because all databases are not created the same, and they don't all have the same nifty types of cool things that you can do, automatically by using certain methods on that database. Here I'm defining the name of the column. So I want it to be called ID. I'm saying here you cannot update it once it's created in the database, and it can't be null. So these are things when you design a relational database, like in MySQL or something, they have these exact same attributes on a table, on a field in a table that you can set. So I'm not sure if all databases would have these, but I would think that they probably do, because primary key, these are sort of a given. And so the ID will always be a long, just because, you might have hundreds of thousands of rows in a table. So you want a huge integer. And I think you can just use a regular long instead of an object like this if you want, but I use a long object instead, which these are 100% compatible with the primitive long type. They're they're compatible with each other 100%. So I use this because this is going to initialize as null. It's going to be null when this object is initialized new. So that gives me some leeway when I'm using the Hibernate Entity Manager, and I'll talk about that in a little bit. It gives me some leverage on creating a method so that I have a method called save, and then I can pass in a brand new object or an existing object and just click save, and the method, that method will figure out, do I need to persist it or do I need to merge it? So there's two Entitymanager methods. One's called persist and one is merge, and there's different cases that you would need to use one or the other. So I just created a method that I don't have to worry about it. I don't care. I let the method handle it. And this, using this long object, instantiating to null when I create a new one, that makes this possible. Okay, so now let's move down to other attributes. So we have basic here. Now, if you don't put the basic here, I think Hibernate will still try to persist this item as a basic. It won't try to figure out. I think it will only figure out primitives like this. I'm pretty sure. It's been a while since I messed with this, but I think that is true. But I put basic there anyways, just to be specific that I know this is basic, and that's why I'm putting it, and I'm expecting it to be considered a basic, primitive type. So I don't think you need these if you're just persisting primitive types. It doesn't hurt though to put it there, just because then you're being explicit about your intentions. Here I'm using the column attribute along with the basic. So these attributes can double, they can, there can be multiple attributes on one member variable. So I have basic, and then I also have a column, and I'm telling it that the column should only be size 2, because these are those codes that you saw here, and they only allow you to put one character in a code. And what these codes are is they're simply they allow the user to put custom codes in here so that they can use them for searching, for reports, for purchase orders, and those types of things. And so I have 3 of those. You can see them here. And then, so these are the rest. These are just, stuff that describes this item, an item, not just this particular item. So here, this field right here, which is called notes, I wanted an item so that the user could type in notes that would help anyone who was looking at this item. So it allow you to type in some stuff, extra information, just sort of like this picture shows you what the item looks like. This would be important, let's say, if someone wasn't exactly sure what engine the car had or whatever, so they might have the old one, and they can look at this and say, oh yeah, the brackets look the same, so this would be the one that you need. That kind of stuff. And so the view notes here, this lets you edit it. And so that's what let's see, where is it? Part notes right here. So this is a lob. The type is a lob, which is a large object. And this is sort of I think this is a pretty universal term when it comes to storing large objects into a relational database. And it's stored in binary, I'm pretty sure. But the reason I had to say the column length needs to be 10,000 characters is because if I didn't use this column, I could use this, but the default length, if you just put lob only, that's it's only, I think it's 1024 bytes. And I want the user to be able to type, much more than that. If it's certain, I want them to be able to put a certain amount of information in there. So that's why I use this. Same goes for the picture. You see here the picture URL. I also made that 10,000 because sometimes URLs can be very long. And so this is the URL editor page. So this is that item right there. The rest of these are just basic stuff. So now these are all the pretty much just basic stuff. You don't even really need this so if this is all I had was just primitives, no problem. We're done. All you need to do now is just create the getters and setters. But the thing is we're not done yet, because remember we went to the item here and we were like, okay, here's specific attributes that describe this item, and these are not going to change from one store to the other. If we're going to sell this item at price C, this is the recommended sale price for this item. We're going to sell it at the same price no matter where you are, what store, doesn't matter. And so, but there are other items like order point, new order, quantity on hand. This is a perfect example. So store 1 is not going to have the same number of quantity in stock as store number 2, most likely. So if I click store 2, you see it changed to 7. So store 2 has 7 in stock in their warehouse. Store 1 has none. If I go back to store 2, you'll see there's an order point of 16 here. And there's 1 on order. And the population code here is, or the popularity code is A, which means that's a very good selling number. If we go back to store 1, its popularity code is D, which tells me that's a bad seller. And the order point is 0, which means if you run a new order report on this, it's never going to order anything because it's at 0. And you can see they have nothing on order, so that tells me that they don't even stock this item in that store. So order point, popularity code, all this stuff, none of that's in here in this item. None of those items are in here. Okay? Quantity on hand, you will not see it here. You would think it should be in here, but it's not. The reason is, though, is that the item quantity is based on the store, not on the item. So how do we do that? We have to think about this. And the way we do it is we create, obviously we're going to have a store object that describes the store, and then we're probably going to have a store quantity object as well. That would probably be a suitable way to model this situation. So I just happen to have a store object right here and a store quantity right below it. So I already have those open. So if we look at the store object, it's an entity object. Come down here. We have all our primitives here. We have the ID. Now we have all our primitives. Store name, street address, all that stuff that you would think. Tax rate. So that's something that's not the same. That possibly might not be the same between two stores, right? If a store is in one county and then another store is in a different county, counties set the tax rate, so they might be different. One store might, let's just move on. You get the idea. Here also, this year's sales, total sales, those would be different for a store. So these items right here, those are going to change based on the store. I have no data in here to show that, but that's also part of the store, not the store quantities, but the store. So that's a separate thing. It doesn't belong to the item, and it doesn't belong to the store quantities, which are these. It's just extra information that you might want to see when you look at an item. Right? This is kind of some important information to have. Like, how many sales did we sell of this last quarter? Oh, you know what? We sold a lot last quarter. I think I might want to update. Let's say store 1 all of a sudden started selling this last quarter. So now, let's say it said something like 6 here. That means they maybe had to order or get some items, get some of the store 2's items to sell it. So, well, let's say they're starting to sell this, so let's up the order point to 2, and let's see if it will order this. We'll bump this up to C and hit save. And so now, the next time we run an order, it's going to order 2 for this store. So that's the kind of information you want to have on various dialogues. So if we come down here, we'll see for the store is going to keep track of its invoices. So it has, let me go back before I go into that. So let's go to the store quantity. So the store quantity has, you'll see here, it's an entity. The main thing here is the quantity on hand. These are primitive items. Here's the reorder level. Here's the new order that we saw here. Order point is the reorder level. New order, quantity on order would be this. Number of lost sales is there. Number of cores here. Popularity code, that's there. And down below, though, we have some relationships now, right? But let's go back to item. So we're obviously going to have some sort of relationship in the item to the store quantity and store, right? Because I want, when someone, so this control is a drop-down list, and it has a list of all the stores in it. And so this, remember the GUI that I had showed it previously, it had this control in it. And so when you open a new item, like here, let me try this here. I can just open a new item. So when we open a new tab for an item, it loads this control. It goes out and gets all the stores. It does a query using Hibernate, and then just stores those stores. It loads that drop-down list with the stores, and it loads it with objects. So if you look at the store object, and we go down to the toString object, our method, where is it? Right here. So in Java Swing, I think the default object, or the default method, either that or I had to modify it. It just calls the toString method to get the label to show here in this dropdown. So that's why I implemented the toString to just return the store name. And so that's why it's getting populated that way here. So back in my item, I created a relationship. I'm going to need a relationship between these two. So I'm going to want the stores because I have this action. So I would like to be able to have, as long as I'm pulling in the item, right? I'm querying on item here, not island, item. I'm querying on item, and so I'm going to get a list of these objects depending on my query. So one query would be, I know the exact part number, so if I say 335, I know the exact item number, so I'm going to hit search and it's going to directly load it into a tab. Here, here I did a partial search when I left off a number. So there is no number called 321,333, so it's going to give you, it's going to search and give you everything with 33 in the part number name or the item name. So same deal though, if I double click on this, it's going to load this into a tab, and so the thing that I have is the item object. That's what I'm working with in the GUI code. And so it would be handy if I could just do a search or a query using the Entity Manager with this item number and get an item back, and I have all the information I need to populate this entire UI. And so that's what I've done. If we look at the item, so I have a relation here. I have a few relations here, and these are the attributes, the Hibernate or JPA attributes: many to one, one to many, many to many. And so these are how this is how you're really designing your data structure based on object relational mapping. Okay, when you're thinking about this, you're not really thinking about the relational database, but you are thinking about the relationships between the objects. And these attributes here, or these annotations, should I say, they tell Hibernate, how to create the tables. And Hibernate has other things that you can describe, other annotations that you can use to change the way that Hibernate will create the tables, seemingly to create better efficiencies when doing queries. But you don't need to really use those. This one annotation that you're probably definitely going to use is this fetch type, which is eager or lazy. So the eager fetch type means that when it goes out and retrieves this item from the database, any of these relationships that have a fetch type of eager, it will also retrieve these items from the database at the same time it's getting this item. If you put lazy there, it's not going to bother getting the information from the database for this item, for this attribute, or this object, should I say. If you do access, though, if you end up getting this object back in your code and you end up accessing this item from the code, it will go out and fetch it. Now, I'm not sure, I don't think that works if you're not using the context feature of the Entity Manager. And I'll discuss that later. But there's two ways to work with the Hibernate Entity Manager. One way is to use the Entity Manager in a context. The other one is just to query your item, and then so you open the Entity Manager, you query your item, and then you close the Entity Manager. And then now there's no Entity Manager context anymore. So now you just have this item, and it's basically an object. It's not connected to the database anymore. in that context. So if you make a change to this item, say in your UI, and you want to persist it, you need to get another or create another entity manager, and it will create another context, and then it will merge it or persist that item, and you can either leave it open or close it. And I'll talk about that later, and I'll tell you the difference of what the difference is between leaving the context open and closing it. But for now, let's go continue on with this. So this many-to-one annotation, and it's over this product line. What that means is it means many items can be associated with one product line. Okay? That's what it means. So it just that just means that if you have an item, it can only be bound to one product line at a time. So this item cannot exist or not belong to any other product line except for the one that's assigned to it. So the way you can understand it is like, take the name of the object or the entity object, item, many, because remember it starts with many items can be associated to one, whatever your object is, product line. Okay, so a product line can have many items associated with it, right? That makes sense. But an item cannot be associated with multiple product lines. Why? Because this item I'm going to purchase from a particular vendor, and a vendor is the one who provides the product lines. A vendor has product lines in it. So if we look here as the example, this product line is D31, right, for this item. Now, if I have another item with this exact same number, you can do that. That's not a problem. It'll just probably come from another vendor, and that vendor will have most likely a different product line codes, let's say. So if you look at the product line here, you see it's D31, and if we go into product line, let's check that, D31, this is the record. So this is the object, product line. This is one of the product line objects that's in the database, and its product line code is D31. Product line is AC Delco, reman, alternators, and starters. And it has some information about the product line itself, like when did we take the last inventory on this line? What's the default list price for this line? What's the default sell price? And if you look here, well, I'll show you in a second. How many year-to-date sales, etc. Just information that are going to be used can be used in reports. Help you figure out what's going on with that line. It gives you some information like market segments, the position. This is a premium line of remanufactured alternators and starters. Gives you a description of what this line is. So if you look at here, like the default sell price field is C, we see that price C highlighted in green, that tells the user that, hey, this is the default price that you would sell this at. So if you're going to quote a price to somebody over the phone, that's the one you quote. So when I load this item, this product line it fetches it, and this product line information, which was that sell price, default sell price, I get from here, and then I say, oh, this is the sell price, now shade it, I make it green. Okay, so let's go to the next relationship, this many to one unit measure. Same deal as the product line. A unit measure is this is a piece of metadata. So unit measures, all it is the unit measure name, the description, and the abbreviation. So it's very simple, but if we look here, the unit measure right here, it's not set, but I can set it. So this is each, because it's one item. It's it's an alternator, so it's sold by the each. It's not by the pound or the foot or whatever. And then you can save this. Open this up a little bit. So it's getting, now that that's set, so I just set this on this 321, 335. I just saved that to the database. But when we opened it up to begin with, let's see, let's go back to here. This one's each. About that, no, these are all each. Let's see, oh well, I was going to find another one that wasn't set. But when I first grabbed this, when I first retrieved this from the database, this would be null. And so this would have nothing in it, sort of like this bin location, right? There is no bin location set for this item on store 1. Store 2 doesn't have one either. So so that will be null as well. But the next time, if I set this 321, 321, 321, 321. Now the bin location was saved, so now it's going to get set. So you can see that these, if they don't have any, if they have nothing assigned to it, because that's really up to the user to decide where is this located in your warehouse, this will be null. So this basically just says, same as the top one, right? So many items can be associated with one unit measure, right? And this belongs to the item, right? Because unit measure is not going to change between stores. We're going to sell this the same way no matter what store you're at. So that's why it's in here. So now here's another relationship that when I was talking about all of these, quantity on hand, that's the de facto standard example. Obviously, both stores are not going to have the same quantity on hand. So this is how we get that information. So we have a one-to-many relationship here. And that means one item can have many stores here. And if we go to, and you see it's a map with a key of store and a value of store quantity. So if we go to store, let's go back up here. You see here, there's no relationship in here to store quantities. Okay? None at all. Because like the store is something that describes the store, right? The address, certain things that are relevant to the location of the store, like the tax rate. Do we tax cores at this store? Generally no, maybe, but the other store does. The total sales, and then you've got your posting date might be different. You might want to know the company if you retrieve a store. This is sort of a nice to have here, so that way you don't have to go. So when you open this up, or when you retrieve a store from the database, you automatically get the company information as well. And you're going to want to know, you're probably going to want to know, I want to know all the invoices for this store. So you get those as well. And you definitely want to know the associates, like the employees that work at that store. So when you retrieve a store, say by the store name or the address or something like that, depends on how you define your query, you're going to get all this information just by returning the store. But a store has no need to know anything about the items that might be stocked at that store. That's not the job of the store. The store is just the store object tells us about the store itself. So we don't need anything in there. If we look at the store quantity, we have all of those items that are relevant to a store, right? And it has a relationship, so many items can be associated with one store, right? So store 2 or store 1, let's say 2, because it has a lot of, if I go forward, I can scroll through the different parts for this particular store. See, so store 2 has many items associated with it. See, these are all store item, and that's what this means. It means a store. Many stores can have many quantities, item quantities can map to one store. That's what that means. Many store quantities can map to one store. Okay. Now if we go back to item, this is a map with a key called object. The key to the object is a store object, and the value is a store quantity object for this item. And so because of the relationships, Hibernate knows that it's going to return me a map of stores with the key of the store object itself and mapped to the store quantity value for that store. So when I'm here and I click store 1, so remember this UI, this drop-down box is storing the actual object, the Java object for a store. And so when I retrieve this item, it now has this map. So when the user clicks this, that triggers the code to grab this map called store.get, and pass in store, and it's going to return me that quantity for that. And then I can take that quantity and I can update these values here, as well as these and this and this. So that's how this one-to-many works for a relationship between an item, the store, and the store quantity. Very nice. Very, very elegant way to do this. So now with this relationship, you can kind of start to see the power, or just the how nice it is to develop it with this capability. And this many-to-many, what this means, so if I look at the item metadata object, all this is a name and a string value for that name. So you have a metadata name, and then you have a value for it. And it also has a relationship to items. It's like they both have a relationship to each other. So you see here, I have, where is it? Item, right here. So I have a many-to-many with a set to item metadata, and here I have a many-to-many to a set of items. And so basically it just means, right, item metadata, many item metadata can be associated with many items, and vice versa. Many items can be associated with many item metadata. So if I was doing like a search, let's say, and these, so you might have a name, an industry name that referred to an alternator, other than the word alternator. So that name, that industry name would be, you would have an entry in here like, generator. Generator is different from an alternator, but some people still call it generator. Generator is not an alternator, but sometimes it's used interchangeably. So you could say you could put the word generator here, and then the value would be alternator. So if someone searched on generator, you could find, you would find this alternator, because this is basically what that is. This would have alternator here. So then you could, if you basically do a query on the database for generator or alternator, depends on how you structure your query, you're going to get a list of items that have this metadata associated with it. Let's see here. Anything else here? Oh, nothing else here. So I think that's a good overview. We can look at the database now. So if I do something like item, let's do a select on items. So here's what the database looks like in the relational table, in the table. Here, all of these columns, you see the names here. If we go to item, you can see, price A, you see price, where is it? Oh, here. Core price A, right here. Core price B, back ordered. So all of these names, we go here, here's the price, there's the prices right there. So Hibernate, you can see that I did not direct it to create a certain name for the column that just said, okay, you named it price A, I'm going to name it price A for the column name. But here, the ID, I told it, name it ID, which might be what it would have made it anyways, but here it named it ID. And so this is everything that is contained in the item object. You see there's no quantity on hand here. There's no new order or order level, reorder level. There's none of that stuff that's in the store quantities. So if we look at the store quantities, first let's look at store. So I'll look at store here. Oops. Execute. So you see we have two stores, store 1 and store 2. And their IDs are 3 and 4. So store 1 is 3 and store 2 is 4. So now if we look at the quantities here, we see these are items. So these are representing an item quantity, or quantities and new order and all that. These are all those items from here that we said that they're not part of the item number. They're separate. So Hibernate created this table to handle that. And you can see here the store ID 3. So this is store 1. These are all for prices. All this information is for, not prices, quantity on hands, let's say, for this store. Go down, let's move down. Oh, and then there's 4. So that's store number 2. And it has different information there. Okay, let's see. So here's the join. Here's the another table that it created. Okay. So this is going to join the. This is a. I forget what they call this table in SQL or relational database. I think it's a join table, or it's an intermediate table. So basically, takes an ID. So this basically allows it to say relate an item. So this is, say, an item. This is one of those items. Like, so maybe this is an alternator, and a store ID and store's key. So this is enabling it to let's see. This is enabling it to take this information and map it onto the item, right? So item right here, where is it? Yeah, right, item, store quantity. This table allows this information to be connected or to be joined to the item table. Okay, so Hibernate did all that based on the way this was written. So this relationship caused these tables to be created. So I didn't create any of these tables. Hibernate did all of this. So when you start your application, let's say, with a brand new database, let's say you have a database and you called it something, and MySQL makes you create a database. I don't think Hibernate actually creates the database. You have to create it, and all that is, SQL Server makes you do that too. So you have to create a database and give it a name, essentially. So let's say I created, here you don't have to do that. So HSQL is a little bit different. But if this was MySQL, I'd have to create a database and give it the name, say, Imanager. And then when you describe the database to connect to in the application's properties, you would give it that name. So, but all you have to do is just create the database name. It's called creating a database, but all you're doing is pretty much giving it a name, and then you have some configuration items you can configure, like some security items and other various things like that. Stuff that you would just do once generally, and then the database itself would manage it from then on based on your settings. And so, but there would be no tables created. And so the first time, let's say I created a new MySQL database, the first time I launched this application for the first time with that new database, Hibernate would connect to the database and create all these tables with no data in them, but they would just create them all there, and it would be ready for you to use. And then the next time you ran this program, they would already be here, etc. And that's how that works. So you don't have to ever mess. If you don't want to, you never have to go into the database manager and look at any of this if you don't want to. But like I said earlier, there are some Hibernate attributes or annotations that you can put on your objects that will give it hints that you want tables to be like these types of tables, these join tables. You can tell Hibernate to make these types of things in a different way. So if you're doing certain types of queries and you want more performance, you can, and you know what you're doing, you can do that. But let's go on to the Entity Manager. So the Entity Manager is part of the Hibernate API. It comes with Hibernate. And you also, I can show you real quick. Not that. Oh, also, well, I'm not going to go into that. But let me go here and open. So when you create your application and you're going to use Hibernate, you need to create this file called persistence XML. And what this does is it tells Hibernate, it has these things called persistence units. So here's one. And this one is the Imanager-HSQL. That's the name. That's the name that I gave it. And I'm giving Hibernate some information. So I'm telling it to use the JPA Hibernate persistence provider, and then I'm listing all of my classes. These are all my entity objects, and you need the full path, the URI to the URI, the fully qualified path to your class. You list all of your classes that you want to be persisted, and then you have a section called properties. Now these properties are the things that tell Hibernate how to manage the connection to the database, what kind of driver you're going to use. So it's a Java application, so I'm going to use the JDBC driver, and then I'm going to give a default URL to connect to the database. I'm going to tell what dialect you want me to use. And Hibernate has a ton of different dialects. So, this is the HSQL dialect. If you were using MySQL, like I have another configuration for MySQL, and then you would use MySQL 5 NODB dialect. And then I have one for PostgreSQL right here. So you use the Postgre. So, because what I mentioned earlier was that each database has some quirkiness, or it has some different capabilities that you won't find from one database. It's not a standard, so databases are free to allow you to create capabilities that will improve performance or do, other things. So, and then there's the username and password. These are just placeholders. These are just, a placeholder here, like a default. However, when in your application, so this is going to be compiled in to your app. So this is not something the user would change. You are going to create a configuration property file if you want the user to be able to change any of this stuff, any of these items on the fly to configure. So obviously one of the things you're going to want to allow the user to configure is the database URI or URL, right? Because their database is, who knows where it's going to be. And also the username and password, they're going to need to have a place to put that. So in your application, in my application, I'll show you, if you go up one from the bin folder, in the conf configuration folder, you'll see these persistent.properties files. And I have one for each database that I currently have it configured. So HSQL, MySQL, Postgre. So if we go in the HSQL file, you'll see here's where the user can put their URL to their database somewhere on the network, and put your username and password in there. And then when the system comes up, it's going to read this file, because in the batch file that I used to run this, I list it somewhere in here. Where is it? Yeah, so here's the iManager persistent unit. It's going to be iManager HSQL. So the system knows when it sees this to open that file. And it will read those property values and use them to open the database. Most of this other stuff in here, these are the C3PO library helps. This helps for keeping the, managing the connection to the database, because the databases, most of them you can't just connect and it'll just keep you connected forever. I think it tries to figure out if you're not using the database, it's gonna terminate the connection. So there's different things in here like that, but that's what you need to tell Hibernate what objects you're going to be working with. And so what you have is, so here's a file, Hibernate Data Manager I created, and it looks for that key. So this persistent unit key is pulled in from that batch file, and then it checks to see, oh, is it this? Okay, yes. And then it gets the MySQL properties. If it's the and I have a utils folder, utils object that has these properties in it, and it sets that to that. And then let's see. Oh, and here, so here's the thing. This is a static class. It has everything's static because it's just going to be loaded. It's needed at the time of execution of the application. So Entitymanager Factory, you have to create this first because the factory is going to let you retrieve entity managers. And so this should be created at the beginning of the application startup. So, because this is the expensive thing to create. The entity manager is not expensive once this is created. Okay, so this all happens on startup. It creates an entity manager factory, gets the database you're using, so that the Hibernate knows what all your objects and what database particular things need to be used to connect to that database. And then I created this Hibernate Entity Manager package just so I wouldn't have to use this in my code. I could just use this class and instantiate this class into a variable and then call this get entity manager. So, but this is what you would use in my setup to get an entity manager, create entity manager. And so this is the actual class that I use in my code. So I call it Hibernate Data Manager Dyn. And what I do is the first time this is used anywhere, it creates a, let's see, it creates a thread local, and it creates a thread local, and it sets it to this variable called EMF, and it's the Hibernate package entity, or Hibernate Entity Manager package, which is this. So it creates one of these and then stores it in the thread local variable, so that the next time anyone instantiates one of these, it will grab it from here. It's not that big of a deal, but this way I don't have to, instantiate this every time I create this, because this is meant to be used all over the place, using newing a new Hibernate Data Manager Dyn, and then use it, and then let the garbage collector tear it down. And so what this does is what I have in here. So this is what I use in the code to persist objects and retrieve objects. And the way I just have a bunch of methods in here, helper methods, that use the entity manager. So when in my application code, I don't even have to worry about getting an entity manager or anything. I don't have to worry about all of the particulars with saving stuff and persisting stuff. So when I earlier talked about the entity manager early on, and I talked about the different contexts of an entity manager, what that means is that when you instantiate or get an entity manager from the Entity Manager Factory, what it does is it creates this context, right? So if you were just using this, like you could use this in your code, like in the UI code somewhere, and you could call get entity manager, and you get an entity manager, and then you retrieve an object from using that entity manager. Okay, let's say you did that. Now, if you put the data from that object, say in a UI, and someone changes that UI, like just goes in and changes the text, say on a name or something. Let's say there's a username that you want to change the text or the name. As soon as you change the text, the entity manager, since that object is in the context of the entity manager, it realizes that you changed it, and it will automatically merge it to the database. So there may be instances or types of applications that you're going to write that would be helpful on, like let's say you had objects that were displayed on a map, and you let the user drag an object from one lat long to another lat long. Well, you don't really want to, after the user drags it, you probably don't want the user like have a pop-up and say, do you want to save this? Maybe you do, but maybe you don't. Maybe you just want it to change the lat long and persist it, so that the next time they come into the next time they execute the application and the map comes up, everything they move will be in the exact same place where they moved it, right? So that's one use. That's an example of a use that you would use the context of the Entity Manager, but I don't use that anywhere in this application. There's no need for any of that, because everything here is done with deliberately, it's basically, this thing is a big editor for the most part. And so usually most editors, you don't save it until you want to save it, right? You make your changes and you may think, well, I don't want those changes anymore, so I'm not going to save it, that kind of stuff. So I don't do that. So everything in this file, which are all my persistence capabilities, it basically gets an entity manager, it creates one, and then at the end of everything it does, it closes the entity manager. And what that does is it basically tells Hibernate, or the manager, that, hey, we're done, destroy the context and just go away and be absorbed by the garbage collector. And so the reason I did this is, I actually talked about this earlier as well, and I'll go into it now. And I said, why do I need this? Why do I want to use this type of this object, and it instantiates to null? Well, this is going to help me in this package, or in this object, so that what happens here, I can use this save on any object. So I can pass in a new object, and I will pass in that new object's ID too, and that will be, if it's new, this will be null. Okay, so to persist a brand new item that doesn't have an ID already, you have to use a particular entity manager function. So if we look at this, if right here at first, and it's going to do this in a transaction, because other systems might be also updating stuff at another store or something like that on the database. So these are all wrapped in transactions. But anyways, the long is null. Let's say it's a new object. So for a new item, you have to use persist to actually persist it. If this long was not null and it was an actual number, then it would use merge, because the entity exists, and basically what it's going to do is it's just going to look at the object that you passed in, and it's going to figure out which attributes you changed, and it's going to update those columns in the database. But then there's a different thing here. It says Entity Manager contains object. So what this does, it says, is this object already part of the context, the Entity Manager context? If it is, you have to use the persist function to persist it. I'm not sure why, but if it contains it, if this is in the context of the entity manager, you have to use this. So that's why I did this. That way I don't care if it's a new object, an existing object, or if it's in the context of the entity manager, it will work. And then when you're done doing that, you flush it, clear it, and makes sure that everything, that the entity manager or that Hibernate's not queuing it to be flushed out or something like that. And then if it fails, you want to roll it back, so you do that here. And at the very end, no matter what happens, I want you to close the entity manager, because I use these. I don't want any context hanging around. Here I've created a method where you can save all of them. Just give a list. So when I use my import stuff here, import inventory, I can take CSV files that have inventories in it, item numbers in it, with their prices and all the other data, and it will import it, and I can use this. Just read the CSV file in, create objects out of them, and then call this. And so that's what all of these things are. They're just accessors and setters. They're setters and getters, basically. That way I don't have to really deal with Hibernate in the back end. I suppose this would actually, if I wanted to not use, if I wanted to get away from JPA and just use objects and roll my own SQL, relational database stuff, I could just still use, none of my code would have to change, right? Because all I would have to do is use these same methods, but I would have to change all the code in here to actually access or use SQL, which I would never do that. Because this is, Hibernate is really a luxury, in my opinion. It's very, very useful in many, many ways. This is much better. But I hope you got the gist of this now, or gives you, and I think this is a decent overview. These things right here, these are called named queries. So in this thing here, this class, it uses named queries all over the place. So item by item number, right? That's a named query. So you say create named query, and you just give it the name of it, which is here. So item by item number somewhere here. Item by item number right here. So this is what the query looks like. And you can get pretty item line store dot new order. So you can get pretty sophisticated with them. I haven't gone into real super crazy queries yet, but you can create some pretty in-depth queries. But I hope that this helped you out a little bit, or at least gives you an overview of how Hibernate works and how you would use it with Java, plain old Java objects. Okay, so if you have any questions, I'll put a link below to the URL for this application if you want it, if you want to mess around with it. It comes with the HSQL database, so you don't have to download anything else to use this stuff. I find that I only use this, you would only probably use this for developing So it's very handy for that. That's for sure. So if you have any questions, please create a comment, and I'll try to answer it if I can. All right, have a nice day.